right, everybody, I think we'll go ahead and get started. Welcome to our third in a series for the Lunch with Larry. We're in a series of 5 different webinars to discuss design control. This is our third, which is really systems modeling, model-based systems engineering. How is functional modeling built and how does it relate to requirements management? So that's the topic of the day. Look forward to getting into it here. I'm going to go ahead and. So today, Michael Bowman is the president of Fox Solution. They're a systems modeling and requirements management solution provider in Germany. And just a couple different details about him. As we get through this presentation, I think you'll find his expertise to be excellent. And if you have to drive your project and develop some pilots around this kind of work, this is just Michael and his detail and contact information. So thanks for joining me today, Michael.
Yeah, it's a pleasure.
Thumbs up. All right, so I'm going to go ahead and just dive in. When we talk about design control, this is a little bit of a review, but when we talk about design control, there's really requirements management is the key centerpiece of this, the center data. But when we talk about requirements management, really a 1A and a 1B to requirements management is systems modeling. And the reason for that is the source or understanding of how to develop the requirements is really developed from systems modeling and the functional modeling. So this is a very of getting your requirements management right. If you deploy these in order, I would probably suggest systems modeling and requirements management first. Second thing is really standards management, external standards and how we develop those. We talked about those last week. Verification and validation we'll be talking about in 2 weeks after Thanksgiving. And then finally, the last one will be risk management. How do we integrate the data model for evaluation of risk in the context of systems modeling, in that using requirements management as the key core. Development methodology that I would suggest that you use as you try to develop a new requirements management solution. So I'm just going to talk a little bit. This slide is a little bit of review, but let's talk a little bit about systems modeling and the development of functions. When we develop these systems models, the functions are really black boxes. And if you think of it this way, we have inflows to the black box, we have outflows from the black box, and the functions represent what happens inside the box. And the reason we do this is so that we have a very clear understanding of what we're writing the requirements. And I think one of the problems that we run into when we're is that when people do that, essentially they sit down with a Word document and just start writing what they believe the device needs to deliver. There's no methodology that they're using for development of those requirements, so therefore they don't know when to finish. What is a full set of requirements? And I think this discussion about functional modeling is going to give you a better sense of how to methodically go through your design, understand what are all the elements that need requirements written against it, and have a justification and an understanding of how function drives the requirement set. And that's really what this is all about. So what is a function? Function's really, as I said, a black box, and it's a verb-noun combination. So delivers vacuum, regulates pressure, sets a digital pressure level. So these are really a verb-noun combination is what defines the function itself. And in this case, we're going to talk a little bit about regulates pressure. And that pressure regulation is the function that's going to be delivered. Now, when we talk about an individual function, what we're talking about is something that's delivered in one component of the system. And that'll become important because there's a difference between functions and functional chains, between design requirements and system requirements. And we want to have a formal separation between what is a function and what is a functional chain. In this case, again, this function is regulate pressure, and the purpose of the function is to transform the inflows to the outflows. So the function is to do that. So how do whether it does what it's supposed to do is really what the requirement defines. The requirement defines what that outflow needs to look like so that we can establish that the function is doing the work. So in this case, we have an inflow that's 100 psi, or an inflow that's a control, and then an outflow that we're going to regulate the pressure down. We're going to do it to some specification that is that defines what that outflow needs to look like. So Michael, I don't know if you have any comments on this, but this is sort of the first step is what is the core element of a function?
Yeah, it
Any
was
thoughts?
also for us to get the awareness and to think about what really the function is doing. So to get the transition from the inflow to the outflow, and what is my capability of the system, perhaps. So that's a real deal breaker or a big step forward when you're thinking about that in this methodology environment. Yeah.
Sure. Okay, so when we start then and we have this function that is regulates pressure, what you're going to find is it's not going to be uncommon that you need to break that function into more granular components. And that oftentimes happens because we're evaluating risk. So we'll say something like, we have a pressure regulator that we can regulate to plus or minus 10 psi. But in this case, because we have a risk that's associated with overpressure, we're going to have better control. So you realize that the output needs to be plus or minus 1 psi, which the standard regulator doesn't provide. So we're going to have a closed loop system. And in that case, what we do is we expand out the function, and then we put sub-functions inside of it. And each one of those sub-functions are going to be delivered with different components. So if we want to supply the air or convert pressure to an 8-bit level, convert the volts DC to digital, whatever we need to do to get that sort of control, we identify those functions, and then what we do is as a chain. So when we chain together functions in different components of the system, those chains are what we're going to identify as a system requirement. And so in this case, we're going to regulate pressure as the same function we had before, but there's going to be functions inside of that function that deliver the overall chain. And we can continue to do this. So one of the things that we need to be able to do is identify a function that needs more control and then explode it out and provide more definition. And really, it's an engineering question how deep you want to go. You can continue on subsystems as deep as you need to get the level of control that you're really looking for. So this is really an engineering question of how deep do I need to go? And the system needs to be flexible enough to say, okay, I'm going to stop at this regulate pressure level because it doesn't drive risk, and I can identify the output of that function, and it's fine. So that's what we're going to stop at. But as you evaluate it, you might find that in the future you change, and we have a need for more control, so we need to expand the system out. And that's really what this transformation. So we have outflow, and again, we write a requirement against the overall system function. So now this requirement ends up being a system requirement, not a design requirement. So if that makes
Larry?
sense, what we're trying to do is provide a way to decompose it. So yeah, go ahead, Michael.
Yeah. For me, it was also important, and for my team, that it's an agile process. So be aware of you start with a certain level and you break it down, and you will see on the way down, okay, we have to level that up or level down, break it down, or summarize something. So it's important to be or to stay agile, and not to say, okay, we check mark this level and go forward and never touch this level again. It's important to reflect these level to it's then also part of the design control to review the designs we already made, the functions we already wrote down, the breakdowns, the decompositions. It's when we're telling about one function and break it down to subsystems. So that's very important to be in this process and also in this loop.
You bet.
Yeah.
So I'm going to go ahead and just this is a preface to what Michael's going to talk about here. So this is a little bit of an abstract discussion. We're going to get to the actual tool itself, but a product capability is where we start with this process. The product capability are decomposed by functional chains, and the functional chains are decomposed by functions. Functional chains go across components of the system. Functions are delivered in one component of the system. And part of the reason for that is so that we can identify what discipline that function is going to be deployed in. And this will become important for risk later. So when we correlate that then to the requirement set, the product capabilities are correlated to the user needs. And that's really what does the system as a whole do. The functional chains are subsystem requirements. So if we want to do system or subsystems, that's what the functional chains are related to. And then the functions are related to design requirements. And the important part about this is when we start to do risk management, we're going to be looking at a systems failure mode analysis that analyzes the functional chains and the system requirements and the design requirements. Because they're deployed in one component of the system, we now know whether it's software or hardware, formulation, whatever the discipline is, and the different FMEAs that we're going to be using to identify what the requirement set needs to be to control those risks. We need to understand what the discipline is because the FMEA format is different. So this is really the traceability as we go across between tools, between the systems modeling tool and the requirements management tool. But in addition to that, we're going to do a decomposition from in the systems modeling from an operational to a system to a logical and a physical layer so that we can identify what those components are. So Michael's going to talk about that as we go forward here, but this is just to sort of get you oriented to the terminology and some of the higher level concepts so that as he talks about it, it makes sense. So Michael, any comment here?
It's also a good overview that we will start then with the left side in Capella with our architecture modeling tool, and the requirements and everything else we will show also later in Polarion on this page. So you see also the columns on the left and on the right, and to get both tools together, it's the main part are these functions and how we write requirements. So when we start with slide
All
8.
right, so dive into the tool. It's all you.
Right. Yeah, we're starting now on the highest level, on the capability level of the system. And you see right here now the different actors on the right, the patient support givers, the hospital system on the left, on the bottom. And it's all about, you see the picture on the right, about a ventilator. So when you're thinking now about the main capability of a ventilator is, of course, and you see that in the middle, the deliver ventilation. Larry will also highlight it, so it's easier for you to see. And another capability, what that perhaps you also get a feeling, what is a capability, because it's in the beginning not so easy as it looks like. In the middle, on the top, there's a support wheelchair install. So also something like that is a capability of the system. On this level, we can also or start to break it down. So when we're going into this deliver ventilation capability on the next slide.
And maybe just to point
Yeah,
it before we move on,
yeah.
this operational level, the purpose of it is to look at the whole design space without considering necessarily what we're going to provide as a system, right? So we're just trying to saying,
Mhm.
what's everything? Let's talk about the entire space. What if we're going
Yeah.
to deliver ventilation to a patient? What needs to happen? Not so
Yeah.
much what are we selling, right? So it's really a high level view.
You see also the interaction between now the clinician on the right and the patient, and the capability is between both. So that's also a mark you
And
have
important.
to mention. So when we're
Oops.
breaking down this capability, you see different modes. And you see on the left the patient assist control mode, the AC mode. For our example, we will focus on this mode, but you see also there are other modes which are of course then possible, and you see it's kind of the first breakdown we make, that we have to deliver ventilation, and it's breakdown into these different modes, and we will focus on the AC mode. You see now on the next slide, we're thinking about what are the steps to get to this mode. And so you see right here also with the also again in the big gray box, the patient room, and on the right side, the hospital floor. So it's a very high level thinking of where we are. And we separate then the patient room into the patient support, caregivers, the clinician in the room, and the steps right there. Now you see different colors around the yellow boxes. And in the legend on the right, you see what these colors are meant to be. So for example, we'll start with connect to patient, and the clinician is establish operating modes, going further to connect to patient. And then this action delivers now then the connection to the patient who is receiving this connection. And it's in the first point of view, you think, okay, it's you see that directly what we're doing right here, but for me it was something like the second yellow box on the patient side is convert ventilator air to blood oxygen. It's very important to show also that in the system diagram, because we have to deliver something that the patient has to transform and also to do again. So that's really important also to face these actions, functions. Yeah, right. Larry, something to add on this slide?
Well, yeah, and it's an interesting thing because if the function that the patient's delivering is to convert the air to blood oxygen, you could do that outside the patient if you chose to, right? So this is one of those, you're starting to make decisions about what the system needs to do. And maybe you talk a little bit, this is the top level or the very beginning of building out your functional chain, right?
Yeah, exactly. So when we starting with the next slide, we are now facing then the first time the system. And we are on the first level, on the system architecture level. And you see again on the left side, the patient in the middle, in the dark blue square, the ventilator system. And on the right now, the patient support caregivers. You have in the green boxes the different functions of these. We call the lighter blue boxes the actors, and in the middle is the system. And we have now connections between these green boxes, and these connections are then called functional chains. So yeah, you highlighted it already. We are
All right.
concentrating
Just
still
re-highlight.
yeah, the deliver AC mode. And you see it's also highlighted in the middle of the right actor at the patient support caregivers. They are start stop the ventilation. And this function
Oops,
drives
not
into the
reversed.
system.
Hold on. My apologies. I was just going to re-highlight. Go ahead. Sorry.
Yeah. This function chain drives into the system. It delivers the assist control mode, what we are talking about all the time now in our example. And if you follow the green line, then it switches to the yellow. It goes through the function of deliver ventilation through a double lamp, and that will then deliver the ventilated air to the patient, who is then converting that ventilator air to blood oxygen. So you see then the functional chain from the clinician through the system to the patient. It's the first level out of three. So we have now the first level, the system architecture. The second level is the logical, and the third will be the physical. But let's move on to the second level.
And
With
just
this,
to throw this out
which
too,
yeah,
the purpose of this level is to break out and make specific the thing that we're going to be selling, right? So the CR ventilator is actually what we're building. And what we're trying to do is separate what we're building from the rest of the design system. So the patient, the caregivers, the clinicians, all those
Yeah.
people are still part of the overall system, but the box that we're building, for lack of a different term, is in the box. So if we want to say we're going to measure patient vitals and we want the clinician to do it, we would have an idea that that function would be under a clinician. If we want the box to do it, then we put it in the box. And so this is just a generally what are we trying to put in the box that we're going to be
Yeah.
building and how that's separated from the rest of it, right?
Yeah. Right. So when we move on the second level, it's in my, I always take a cube example. We are turning in a vertical way because we break down, we decompose the functional chain, and we decompose the system. We still have the system in the middle, and now we, because of the decomposition, we add several parts of the system. And when we start with the functional chain again on the right with the start-stop of the ventilation from the patient support caregivers, Larry will highlight it. Then you will see that the box is then connected to the user interface. So that user interface wasn't there before on the level 1. So because of the decomposition, we have this element uh, which function is the display status. So that's the function. And we had this function not on the level before. So because of the decomposition, our functional chain will be bigger. We get a better understanding of the system through the breakdown. And also when you're following the blue line, the functional chain again, we will meet functions which we had also on the first level, like the last or the last one, of course, at the patient side, convert the ventilated air. And for me, it's also important. It's every time also with the clients a good discussion to challenge the environment. What's the part and the role of the environment for my system? Is that really an actor? Yes, it is. For example, for us now with the functions, there is it is the supplier for the O2 for the system. And so we have to face also the environment, what is really important for systems. Larry, something to add?
Yeah, this is a great level from the standpoint of, one of the problems that you run into when you're doing this kind of design, when you have a system, but you don't know exactly how the system's going to go together, and that's where this logical level really is valuable. You know you need a user interface, but you don't know, is it going to be a touch screen? Is it going to be buttons? What, physically you don't know how it's going to be set up, but you know that you
Yeah,
have a user interface that has to interface with the patient support givers, for
yeah,
example. So this logical level really allows you to do is sort of abstract yourself from worrying about what that physical representation needs to look like and just start getting that decomposition done so you know what what functions need to be landed someplace in the physical architecture. So it's nice to have this middle layer where you can, have an
yeah,
abstract sort of view of it rather than a physical view.
yeah. And you spoiled now a little bit the third level, the physical level. So on the next level, we are now talking about buttons and the real physics of the system. Like you see or saw, is that we turned again the cube in a vertical way. So we are going deeper into the system. We break down the system into the physical components. You see now on the middle, in the middle bottom, it's still our function of the start-stop ventilation, the patient support caregivers. And now you see the before on the level 2, there was just this interface. Now, if you follow the blue line from the bottom in the middle to the left, there is a LCD display. So we are calling now the components to the system and when you follow the lane, it's to the ventilator software going down to our example, which Larry already highlighted. It's a turbine, and what's the function of the turbine? It's to generate airflow. And all the levels where, if you see that the first time, it's everything. It looks very theoretical, and but when we now show you the example that um, we are writing our requirements against these functions, and that's what Larry mentioned earlier on his slides, and that will help us to get the feeling, are we done with the requirements for this turbine, for example. And to get that, we are not in our cube example, we are not going deeper in the model. We stay on this level and turning horizontal and returning to another tool, to Polarion now, from Capella to Polarion, because we're writing there then the requirements against the function.
So maybe just to draw a couple things into sharp review,
Yeah.
when we talked about the architecture earlier, the lines, this blue line represents the functional chain, just to say it again. And so the functional chain, or the system as a whole, is delivering something that's different than each one of these functions delivers. You can imagine that you got to be careful to write your system requirements in such a way as to discuss the output of the system, not the output of any individual function. So that's,
Yeah.
and now, so if you think about from a requirement set, what is a design requirement? A design requirement is an output of a function that's delivered in one component. So in this case, if we have a turbine and we generate the airflow, the outflow of that is going to be what we write the requirement against. So this is the view of it that really provides you with a formal understanding of the functional use of the device. And what I mean by a formal understanding is we have a diagram that describes not only what the functions are, what physical component of the system they're deployed in, and what those functions are delivering to other functions in the system. And once we have that formal understanding, we have a very clear understanding of what requirements need to be written to get a complete set. And I'll just, one
Yeah.
other thing that occurs to me too is when we talk about usability, really what we're talking about is the interface between, like a support caregiver is a person in the system. They're interfacing with some aspect of the system itself. And when we do an analysis of usability, what we're doing is we're saying we're going to analyze this function that the patient support caregiver is giving, the outflow of that, and how it affects the machine. That's what we're analyzing from a usability perspective. It's the interface between the actors in the system and the system itself. So this diagram also gives you a very clear understanding of what you're going to be analyzing from a usability perspective, which I think is really nice. So,
Yeah.
all
So
right. So
when we
next slide, please.
exactly, yeah, we're turning horizontal. We stay on the same level and writing against this function. We're going to see now Polarion, and you see on the top the function that generate airflow, and then the requirements under it, which are written against this outcome output of the function. So you see, for example, this requirement is written against then the minimum flow rate, or it's also then you have to define then the flow rate so that it's testable. It's a really important part of this requirement. For that, you see also in colors underneath the requirement, we have something that is called a sentence template. So you are always aware all over the company that you're writing requirements in the same way, in the same quality, and have a good quality with the requirements and testable requirements.
I've seen a lot
Yeah,
of this where people write requirements and the requirements are a page and a half long, and the
yeah,
requirements
right.
really constitute 7 requirements in one, and way too much content in a requirement. So this kind of plug-in that you provide really does a nice job of trying to maintain consistency and good practices from a writing of requirement standpoint.
Yeah,
It's awesome.
yeah,
So if we go back then to the physical level, right? Again, that requirement is written against the outflow of that function, right? So as you start to think about these tools, really a systems modeling tool is a graphical representation And by the way, this uses a method. So this is the Siemens Systems Modeling Workbench tool, and it uses the Arcadia method to decompose through levels the different functions, so you can get to a physical representation of what those functions are. Very important to have a complex graphical modeling tool to be able to do that, but it's important also to understand the interface then between the functional diagramming and the requirement set, so you understand how those two things relate to one another. So one of the things I like to say is that the systems modeling gives us a positive view of the design. And what that means is, what do we want the design to deliver, right? What functionality do we want it to provide? Risk management is really a negative view of the design that says, what do we need to have in the requirement set to assure something bad doesn't happen? So it's kind of both sides of it, the positive view of it and the negative view. So this is really, how do we determine what needs to be delivered in the device from a functional standpoint so that we can represent that as requirements in the requirement set. So any other thoughts here, Michael?
No, it's all fine. Guess we're through the whole methodology and good to go.
So just what's the value of functional modeling? And if you've ever had that gnawing feeling that I really don't understand, I have a problem in the testing and I don't really understand functionally what I was trying to deliver, systems modeling really puts us in a position where we understand formally how the system functions. And it also defines for us what a complete set of requirements means. We're not just writing things until we get a half an inch of paper or until we can't think of anything else to put into a requirement set. We have a formalized methodology for walking through the design so we understand what it means to have a complete set of requirements, both system and capabilities or user needs, system requirements, and requirements. This also provides us with a very clear understanding if we identify a fault, right? What do we need to change? And how do we formalize that and drive it through the process? So because we have this formal understanding, if we make a mistake, it's easy for us to say, okay, we're going to change this function, we're going to change the outflows to that function, rewrite the requirements, re-execute the testing, and move on. So it's a very clear problem. One of the things I've noticed in the past is we get into V&V testing, we try to understand why we got a failure, and because the requirement set is so convoluted and we really don't have a formal understanding of function, we just sort of change things in the design, which has an implication to other things in the design. So you can imagine these chains interrelate with one another. Functions sometimes support more than one chain, or often do. And so if we change a function or we change a requirement, it's often going to impact something else in the system. And we really need to understand what those relationships are if we want to have have some kind of a chance of not breaking things when we make changes. So it's really this elimination of requirement subjectivity. So just to state it again, if you need help with a pilot, to give this a shot in your company, Michael is more than willing and able to help you with that pilot. So just either contact me or Michael directly, and we'll get you set up to do a pilot. And then this is just my contact information, as I always put at the end. Registration link if anybody else wants to come. Next session, not next week, but the following week, because next week is Thanksgiving. Will be verification validation testing and talking about reporting structures around that. Registration link is up top. I'm posting all these on my YouTube channel, Lunch with Larry YouTube channel. So got the link there. Subscribe so that I can get out of this GoToWebinar thing, and we'll do it directly through YouTube. So thanks again, Michael, for helping me with this presentation and the webinar. And
thank you
thanks
for the
everyone
invitation.
for coming. Sure.
Yeah.
All right.
Awesome.
Thanks, everybody. Have a great day.
See you.